Okay, so we'll start the session. So today, as I mentioned, I will be discussing two topics, electromagnetism and the radioactive that particle theories as well, right? So we'll start with the electromagnetic section, the magnetism and electromagnetic theories. So I have uploaded this PDF into the group, so you can download it and leisurely go through it. So here I'm going to just refresh all the theory related stuff when it comes to electromagnetic theories, right? Okay, so here, first of all, the foundation of magnetism. So you need to know what are the magnetic materials and what are the non-magnetic materials and what is meant by magnetically hard and magnetically soft. So these things were tested in the exams as well, right? So you need to go through them. So I'm not going to take more time on discussing those stuff, right? And here, the unmagnetized state and the magnetized state, no need of going through that. Only you need to remember that definitions when it comes to magnetic materials and the examples likewise. And here, like poles repel and the opposite ones, they attract, right? So remember that. So we are dealing with North Pole and South Pole here. So when it comes to like poles, which means North Pole with a North Pole, so these two will be repelling each other, and as well as South Pole and South Pole will be repelling each other, but the opposite poles, North Pole and South Pole, they will be attracted to each other, right? And mapping the invisible field, which means the magnetic field here, right? So when it comes to magnetic fields, we cannot actually see them, right? But using different sort of experiments, we can see the directions of the magnetic fields as well, right? So here, the direction is given. Magnetic field lines always point from north to south, right? Show the direction by showing the direction and the magnitude. So this is something special, right? So the magnitude of a magnetic field, it directly depends on the number of magnetic field lines which is going through the surface area, right? So remember, when you are having so many magnetic field lines going through a certain area, then you will be having a greater magnitude of magnetic force. And the uniformity, so this is also another concept. Uniform magnetic field means parallel, right? So this is the most important part. So the magnetic field lines are parallel to each other. So parallel means you are having the same spacing between two lines, right? So they are parallel to each other. And yeah, before going into the next one, so here, in order to identify these magnetic fields, we are doing some experiments, right? So experiment one, experiment two. So when it comes to the experiment, if it is just to observe the magnetic field lines, right? It is just to observe the magnetic field lines. Then we are going with the ion fillings, right? We are using the ion fillings. So try to remember the what do you call that experiment. And if you need to observe the direction of the magnetic fields, right? Direction of the magnetic fields, then you are using the plotting compasses, right? So remember those points and please go through the textbook. So there we have different sort of uh, experiments explained there, right? So refer the textbook and also refer these sort of diagrams when you have them. And the most important part that you need to remember is that you need to observe the direction of the magnetic field lines, right? So direction is pretty much important. So always remember pointing from north to south, okay? Pointing from north to south. And the electricity generation when it comes to a magnetic field. So this is the right-hand swirl rule. So try to remember it. We are using only the current and the direction of the magnetic field, right? So current and the magnetic field, thumb will be giving you the current direction and the other fingers which is being swirled, so curled fingers, they will be giving you the magnetic field direction, right? So here we are dealing with only the current and the magnetic field, right? Current and the magnetic field. No force is being applied there. So remember, if there's only current and magnetic field, then definitely the right hand swirl rule. And further on we'll discuss. So if it is the magnetic field direction and current and the force, the third factor force, then you will be using the left hand, right? And these are some applications you can see. So all the stuff were given in the textbooks as well, right? And the solenoid, right? So solenoid means like a combination of different lengths in wires, right? Something like that. So go through the structures, how the magnetic field changes, right? And here, solenoids use a magnetically soft core, right? These are some important theory points. The magnetic field can be instantly turned on and turned off. Inside the coil, the magnetic field is strong and uniform, right? So if it is mentioned as uniform, then you should know that the magnetic field lines are parallel to each other, right? Magnetic field lines are parallel to each other. Then the Mott effect and the Fleming's left-hand rule. So here, as I mentioned, here we are dealing with current, force, and the magnetic uh, field, right? So instead of you can use force here, right? Then you can easily remember this is going to be FBI, right? FBI, you can easily remember that. So always remember if there's a third factor that we need to discuss, right? Then you are going for the left hand. If it is just current and direction, current and the magnetic field direction, then it would be only the right hand, right? So remember those. And here, some of the facts are given here. No need of focusing on that. But remember, you need to know how to use this Fleming's left-hand rule. So we discussed so many things about it. And also another thing, when it comes to field lines, remember if it is mentioned like this, then it is coming towards you, right? Something like an arrow coming towards you, right? And if it is mentioned like this across, then it is going away from you, right? It is going away from you into the plane, right? Into the plane. Something like going through the book, right? Going through the paper like that, going through the paper, but it is going away from you, right? And in the other one, towards you, coming towards you through the paper, right? Something pointing at you, right? Okay, so go through them and then applying the motor effect, the DC motor, right? There were so many questions from this, right? So in this case, we are applying the Fleming's left-hand rule. So remember that, okay? So this session would be like, make it your way because here we are dealing with small theory parts, right? So, but here you need to focus more on the calculation stuff, right? So the magnetic field lines are like this, and you have to judge the direction of rotation. There were so many questions that we discussed from this thing, right? And here, in order to increase the turning effect, you need to increase the current. You need to use a stronger magnets, increase the number of coils, number of turns in the coils. So see, these are some small theory stuff actually, right? So try to remember them. And the next one, alternating current into sound, you can go through it, okay? And electromagnetic induction, so which means uh, if a wire, right? If a wire is just imagine a conductive material. A conductive material is being like cutting the magnetic field lines. So which means then there will be a current generated. So that current will be known as the induced current. So always remember, induced means because of an external influence, right? So therefore, there's a current being generated, right? When there's a relative movement between a conducting wire and a magnetic field, the voltage is induced, right? Induced voltage is being generated. If the wire is part of a complete circuit, this induced voltage causes a current to flow, right? So if it is a part of a completed circuit, then it will be generating uh, a current. Then how to maximize the induced volt? So the wire can be moved very quickly, having a higher speed, and we can use a stronger magnetic field, and also we can increase the length by having a coiled wire, right? So these are some small stuff that you can remember. Then when it comes to applying of this magnetic induction, right, voltage induction, we can generate power. So for this, we are using generators, right? We are using generators, not the transformers. Transformers is something like another thing, right? So in this case, you can see there are actually two approaches. One will be like we can either rotate a magnet, or in the other case, we can either rotate a soft iron core or something like that, right? So depending on the application, it will change. So here, rotating a permanent magnet within a stationary core. So this is the first one, rotating a permanent magnet within a stationary coil. So the coil is stationary, but the magnet is being rotated. And the other method is rotating a coil within a stationary magnetic field. So now the magnet is placed as a stationary object, right? So these are the two approaches. So depending on the equipment's requirement, it will change, right? The object's actual mechanics, it will change. And so the same theory, right? So for these two situations, we are using the same theory. So there must be a rotation. So once the rotation is there, then the magnetic field lines will be cut, right? So therefore, there will be a current generator. So this is the basic theory that we are using. So somehow there must be a rotation. So that rotation will be uh, causing in a cut of magnetic field lines. So therefore, it will induce an alternating voltage, right? So that is the basic theory. Then here, there's a small summary given, so you can go through it here, right? And finally, about the transformers. So transformers means like changing actually, right? So changing from another phase to another phase to another phase, right? So here we are having the primary coil and the secondary coil, right? So both those coils are connected with a soft iron core, right? So all the things are given here, mentioned here. So you can use these nodes to, like, something like short nodes, right? So alternating voltage produces an alternating current in the primary coil. Okay, so for this moment, all right, so we need the equations. So, all right, equations are given there, right? So for here, I'll write the voltage here as the VP value and current as IP value, right? For the primary value. And the second description here, this creates a constantly changing alternating magnetic field trapped within the soft iron core, right? Then the third one, this change in magnetic field links with the secondary coil, inducing a new alternating voltage. So that is known as the generator effect. So in the secondary coil, the output value, I will write it as Vs and the current value to be Is, right? So the main purpose of a transformer is to, like, change the magnitude of a voltage, right? So here used exclusively to change the size of an alternating voltage. So normally for an alternative voltage, right? Just try to remember it, like we are not using transformers for DC currents value, DC voltages or DC currents. So mainly we are using it for alternating voltages or alternating current, mainly for alternating voltages, right? So here, these are the symbols. You can go through it, right? Then the transformer diagnostic matrix. So transformers can be divided into two, right? Step up transformers and step down transformers, right? As the term refers, step up means you are going to step up, right? The voltage will be higher in the output value, which means the secondary voltage will be higher than the primary voltage. So you can remember it like this, right? VP is at a lower level, but VS is at a higher level. So step down transformer means VP is a higher level, but Vs is at a lower level, which means you are downgrading the voltage or decreasing the voltage value, right? So the construction is given more turns on secondary value, secondary coil. So remember, the voltage is directly proportional to, right? So I write here, the voltage is directly proportional to the number of turns in the coil, right? Number of turns in the coil. So depending on the number of coils in the number of turns in the coil, right? Number of turns in the coil, the voltage will change. So if you are using higher number of turns in the coil, then you will be experiencing a higher voltage. So if you are using a less number of turns in the coil, then you will be having a low voltage. So construction is given. If you need to construct a step up value, then you need to use more turns in the output coil. And if it is step down, then you need to use less number of coils, less number of turns in the output coil. So the here it is given, right? Voltage increases and here voltage decreases. So the application is given. So just imagine you need to get a higher power as an output value, then you are using the step up transformers. And if you need to, like, to downgrade or you need to decrease the voltage value, then you are using the step down transformers, right? So simple stuff. And here the turns ratio, primary voltage over the secondary voltage will be equal to the primary turns over secondary turns. So equation you can use Vp over Vs will be equal to Np over ns. So this is the equation. So you can get marks either writing this equation or writing this equation. Doesn't matter, right? But try to remember and try to write the word equation as possible, right? So in each and every question, if they are asking any sort of a relationship, try to write the word equation, because if we are using these letters related relationships, then depending on the letter, the idea can be changed, right? So just imagine, instead of capital T, in order to write for temperature, you are using simple T. So simple T will be having a different idea, right? Having a different meaning, actually, different meaning. Like simple T can be used for like either for time, and even in some cases for Celsius temperature. So there are they are the small mistakes that you will learn, you will lose 1 or 2 marks, right? So as always I'm mentioning, just like there will be some situations where 1 mark will be also crucial, right? So try to score them, try to score the maximum. So therefore, try to write the full equations or the full relationship by using words, right? By using words. So that is the first equation that you need to remember, voltage ratio. And the second one, so here the second one is this thing, right? So we can write it like the input power equals output power, right? So power can be written as VI, right? So therefore what will happen? V input, sorry, V primary, I primary will be equal to V secondary, I secondary, right? So in order to get that, we are using this assumption, right? We assume that the transformer is having a 100% efficient, and so which means like there won't be any sort of a power wastages or energy wastages, right? So that is the second equation that you need to remember. Then the power grid, the national grid. So in case if they ask, just remember the diagram, right? So the first one, here we are generating power, right? We are generating power. So the same thing, right? So magnets will be rotated, right? Magnets, so the coil will be rotated. So there will be like that cutting of magnetic field. So therefore there will be a voltage generated. So that voltage will be directed towards a power station, and from there we are using a step up transformer. It is mentioned here, right? Step up transformer. So just imagine something like this. So here, if we are using 100, if we are gaining 100 voltage, and we are stepping up up to like 33,000 voltages in Sri Lanka, right? So then this voltage will be, this power will be carried through these wires, right? Throughout the island. And afterwards it returns here, right? At the desired power station, the neighborhood, right? There will be, we are using a step down transformer. So the reason is like we cannot use this 33,000 voltage in our household equipment. So we need to downgrade it, or we need to decrease the value. So therefore, here we are using step down transformer, and here we are using 230 voltage in our normal home appliances. So that is the main process, right? So remember, if they ask about the national grid, then you need to give an answer something like this. And also remember, why do we need to step up at this position? The reason is like here in the grid, right? In the grid, we are having wires, right? So if you are having wires, right, then there will be a resistance, right? There will be a resistance. So when there's a current and when there's a resistance, what will happen? There will be a power wastage, right? There will be a power wastage. So if we supply, just imagine 100 volt in the system, then there won't be anything when if you are at Candy or something like that, right? Somewhere like that. So therefore, in order to minimize this wastage, right? In order to minimize this wastage, so we need to have a higher value in the wire system like this, right? So that is the main reason. So in order to like, transfer the power to a greater distances, right? So that is the main idea of having these 33,000 voltages in the national grid power system. Okay. So go through them. Actually, these are magnetism part. Most of the time they will be asking like, most of the theory parts. And if there's a transformer question, then definitely we need to use these two equations and conduct the calculations, right? So at the moment you are having experience with these questions, right? So I'm not going to take more time on discussing these stuff. So go through this note. I have uploaded that in the WhatsApp community, right? So go through the note. This will be something like a short note thing, right? So, okay. So I will be ending the magnetism part. So remember, we are having just two rules here, the right hand swirl rule and the left hand rule, right? So if it is the left hand, there are three factors, right? Just imagine a moving thing or something like a moving iron, right? Some sort of a thing. So then we are going to use the Fleming's left hand rule, right? And there's another important question that I need to discuss, right? So we have came across this question. So just imagine we are dealing with a proton and moving in this direction. So here, this is the magnetic field, and we'll say the magnetic field is pointing towards the a uniform magnetic field, right? And uniform magnetic field. So this is the magnetic field, and this is a proton, right? So they are asking about the direction of the proton once it enters the magnetic field. So let's say there are some answers. So once the proton at here, first answer will be moving like this, and the second answer will be moving like this, and the third answer will be moving like this, right? So in order to get this, right? In order to get this movement pattern, we need to use the Fleming's left hand rule, right? Fleming's left hand rule. So Fleming's left hand rule is that in this direction you get the force, in this direction you get the magnetic field, and in this direction you get the current, right? So which means the middle finger, right? Middle finger will be displaying the current, and the index finger will be playing the role of a magnetic field direction, and the thumb will be giving you the direction of the force. Now you need to adjust your fingers and adjust your hand and see what is the correct path, right? So the current direction is the movement direction of this ion. So which means the current direction is going to be this thing, right? It will be this thing, current direction like this. So which means the middle finger will be arranged like that. And so this cross symbol means the, what do you call that? Right here, the cross symbol means the magnetic field is pointing towards the paper, right? Going away from you towards the paper. So which means the index finger will be pointing towards the paper, not towards you. It will be pointing towards the finger. So which means the thumb is pointing upwards. So therefore, this will be the correct path, right? So this would be the correct path, right? So remember, there were a few questions from this thing, right? Go through it and try to get the answers, right? Try to analyze and get the answer. So in order to analyze, you need the Fleming's left-hand rule. You can't get it just by remembering the law. You need to adjust your fingers and see what will be the direction, right? You need to adjust your fingers and you need to see what will be the direction, right? And so in order to conclude this magnetism session, tell me, are there any questions related to this stuff? Yes. In order to increase the magnetic power, then we need to use, like, strengthier magnets, right? So soft magnetic cores, they will be like, providing some sort of a medium or something like that. We need to provide, like, the magnets must be having a higher strength, right? Any other questions? Right. So I'll conclude the session for this magnetism part then, right? So if you are having any questions, you can drop me a WhatsApp message, then I will give you the answers, right? So don't leave the session. I will start the other one as well. So that is the radioactivity thing, okay? So just give me a minute, then I will start the session, okay?